Hello, everyone. In this video, we will look at how to simplify radicals and how to rationalize the denominator or numerator. So here, the first problem here, we have a rational exponent, 4 raised to 3 over 2. So what does this mean? We have, if you see an expression raised to m over n, and this means here the denominator n is the index of the radical, the nth root of a raised to the nth power. So the numerator m is the exponent, and the denominator n of the exponent is the index of the radical. Of course, here, if defined, you can first take the nth root of a and then raise to the nth power. So this is a rational exponent. What a rational exponent means. So that means here you have 4 raised to the third, and then take the second root. The second root is just the square root, right? So this equals the square root of 4 raised to the third. That's 4 times 4 times 4, which is 64. So square root of 64, that is 8. Okay, this is 8. Oh, you can first, you can also first take the square root of the second root of 4 and then raise to the third. If this one is defined, and you will get the same answer, which is square root of 4 is 2. So 2 to the third, that is 8. That is 8. And very similarly, so here we can first take the cube root of 125, and then the numerator of the exponent is 2. So you raise to the second power, or squared. That is 5 squared, which is 25, So this is what a rational exponent means. And in the next example, here we need simplify radicals. And here, this is square root of 45. 45 is not a perfect square root. It's not a perfect square, right? But this 45 has a perfect square factor, right? You have 45 equals 9 times 5. And this 9 is a perfect square. That's 3 squared, right? So here, to simplify, you can write this square root of 45 as square root of 9 times square root of 5. Okay, then x to the third. How to simplify this? Let's say x is positive here. How about we assume x is positive, non-negative? So we use the following property: square root of x squared, and this equals the absolute value of x. When this x is greater than 0, greater than or equal to 0, it seems we can just cancel the square root and the squared, and this becomes x. So if x is greater than 0, and we can just cancel them, square root squared, so equals x, okay? So we use this property to simplify square root of x to the third. You have square root of x to the third, that is x squared times x, right? And then very similarly, 20, you have 4 times 5. So 4 is a perfect square. So you have 7 times square root of 4 times square root of 5. Then x to the third, that is x squared times x, right? Since here x is greater than 0, x is greater than 0, x squared square root x squared. You can cancel them. And the square root of 9 is 3. Then you have square root of 5. Then you have a x times square root of x. And very similarly, you have 7 times 2 times square root of 5 times x times square root of x. And now we can rewrite. So you have multiplications. You can write 3 times x. And then square root of 5 times square root of x. That's square root of 5x. And very similarly, you have 14x times square root of 5x. And now we can combine them. So here, x square root of x times square root of 5x is a common factor, right? So we have 3 plus 14, which is 17, then times x square root of 5x. Okay. So here you should be very careful. We cannot add 45 and 20, right? That's not the way we add. We should simplify. Then you see here x radical 5x is a common factor. Factor that out, you have 3 plus 14. We first write this 125 as square root of 25 times square root of 5. Then you have x to the 7th. So you can have x squared times x squared times x squared, right? So that's x to 6. Then one more x, right? So this is 5. You cancel this square root square root square. So you have 3 x factors. So that's 5 times x to the third. And then you have the square root of 5x. Okay. So this is the way we simplify. Here you have square root, right? And let's say, how about q root? How we simplify? If q root, you should look at perfect q's. So we use the following one: the q root of x to the third, and you can cancel the q root and raise to the third. This is x. This is x. If, just for example, let's say, oh, I want to simplify this one. Q root of 54x to the 7th. So this is the q root. So we look at perfect q factors. You have 54, that is 27 times 2, right? 27 is a perfect q times the q root of 2. And then for x to the 7th, you have q root of x to the third times another q root of x to the third. Then one more x, q root of x. So you can cancel them. Q root of 27, which is, it is 3. Then q root of 2. Then you have x times x. That is x squared. Then times the q root of x. So simplify, we got 3x squared q root of 2x. Okay. Okay, so we know how to simplify radicals with variables, right? You just find perfect Q square factors and perfect Q factors if you have Q root. Okay, the next one is sometimes you might have fractions with, radicals in the denominator, right? Square root in the denominator. And you can multiply by the conjugate of the denominator. If you have a plus b, you should multiply by a minus b. So anyway, they are conjugate, right? 1 plus times 1 minus, right? A plus b times a minus b, this is a squared minus b squared. So we use this formula. And the first one, there's only one term in the denominator. So you can just multiply by itself. Radical 5, radical 5. So the top is 2 radical 5, and the bottom is square root of 25. And we know it is 5, right? So 2 over square root of 5. 2 square root of 5 over 5, okay? And the second one, so we multiply by its conjugate. If you have minus radical 7 minus radical 5, so you should multiply both the top and the bottom by radical 7 plus radical 5. Okay, so here, the denominator, you can use that formula. Use that formula, that's square root of 7 squared minus square root of 5 squared. Or you can FOIL, it doesn't matter which way you use. Let's say here I use the formula. So that's square root of 7 squared minus square root of 5 squared. And keep the top because sometimes they are some common factors. We can cancel them. So cancel them. We have 7 minus 5. And the top is 4 times radical 7 plus radical 5. And here, this is 2. The bottom is 2, right? 4 over 2, that is 2. So you cancel the common factor 2. Or 4 divided by 2, that is 2. So you have 2 radical 7 plus radical 5. Keep this in the factor form. Okay, thank you.